Hello, and welcome to the double/half angle identities day 2 video. This is the last of the new material for this unit, and it's really practicing a lot of what we already know. So for the first few problems, we're going to be taking a look at our double and half angle identities and finding exact values, and then we're going to do a proof together, and that's going to be it. So hopefully this video will be short. So the first problem I'm going to give you is 2/3 of sine of 75 times cosine of 75. And I'm asking you to find the exact value here. So the problem is that we don't know sine of 75, we don't know cosine of 75, so what are we supposed to do? Well, for this problem, I'm going to give you a hint to factor out 1/3. So if we take a look at this problem and we factor out 1/3, we get 1/3 times 2 sine of 75 cosine of 75. Now, again, these are degrees. I should have written that in there. So those are degrees. I can't factor out 1/3 out of the 75 because the sine and cosine are being applied to it. But I take a look at this and I go, you know what? 2 times sine of some angle times cosine of some angle, that looks like our sine double angle identity. So I can really say inside this parentheses that is 1/3 times sine of 2 times my angle. So in this case, 2 times 75. So I was able to do that because this is my sine double angle identity. So now when I take a look at this, I go, okay, well, 2 times 75 is going to be 1/3 times sine of 150 degrees. And I'm like, oh, I know sine of 150 degrees. That is on my unit circle. Sine of 150 degrees is 1/2. So what I really have here is 1/3 times 1/2, or 1/6. And that is my final answer. So I was able to look at this and go, you know, this isn't immediately familiar, but after I factor something out, it does look like one of my identities. So let's try that again. Ooh, there we go. So if we take a look at number 2, that's going to be 8 times cosine squared of 105 degrees minus 4. So again, I look at this and I go, okay, so cosine squared, we're multiplying by something, we're subtracting something. What should I do? Well, I'm going to give you the hint to factor out a 4. Now, I'm giving you hints here, and I'll give you some in the Go formative as well, but if there's a problem like this on the test, I'm not going to give you a hint of what to factor out. I want you to be able to identify the identity on your own. So, for instance, if we were to factor out a 4 here, I end up with 2 cosine squared of 105 degrees minus 1. And I take a look inside this parentheses and I go, hey, 2 times cosine squared of some angle minus 1, this is one of my cosine double angle identities. Okay, so I was able to factor something out and we got an identity. So since that's one of our cosine double angle identities, it's going to be 4 times cosine times 2 of our angle, all of our parentheses, of 105. So once I multiply the 2 and the 105, it's going to be 4 times cosine of 210, and I know cosine of 210, that's on my unit circle. So this is going to be 4 times the negative square root of 3 over 2, since 210 is in quadrant 3. So this will be negative 4 square root of 3 over 2 once I multiply those together. But 4 and 2, I can factor a 2 out of each of those and get negative 2 times square root of 3 as my final answer. So once we factor something out, we get something that looks like one of our identities, and we go through using our unit circle skills and solving. So those are some of the types of new problems that we'll have. But I also want to remind you, we haven't done any proofs yet with our double angle or half angle identities. Now, the proofs are kind of just the same. You take a look at your identities, you use your sheet and those skills. So I'm just going to do one problem with you here, and I'll leave a few more for you to do on the Go formative that we'll go over together in class. So for this proof, we're going to have tangent of b plus cotangent of b is equal to 2 cosecant of 2b. So remember, I can start on either side of my proof. I noticed that here we have a double angle identity with our 2b, but it's of cosecant. So it's going to have to be 1 over sine of our double angle identity. So we can start there. I'm going to start on my left side with tangent of b plus cotangent of b. If you started on the right side, you should still have logical mathematical skills in getting to here, but just with teacher foresight, I'm going to start on this side. So I'm going to say that tangent of b plus cotangent of b, so I'm identifying this is the side I'm starting with. I'm going to change everything to sine or cosine. It's going to be sine of b over cosine of b plus cosine of b over sine of b. So I look at this, two fractions. If I want to add them together, I need common denominators. So I'm going to multiply that left fraction by sine of b over sine of b. I'm going to multiply the right fraction by cosine of b over cosine of b. So that's going to get us sine squared b over sine of b cosine of b plus cosine squared b plus sine of b cosine of b. So now that we have common denominators, we can add these together and get sine squared b plus cosine squared b over sine of b cosine of b. And I take a look at this and I go, ooh, you know what? This numerator right here, sine squared plus cosine squared, that's one of our identities. Now, it's not a double angle identity because we're not subtracting these, but this is in fact our first Pythagorean identity. So this just becomes 1. So this is going to be 1 over sine of b cosine of b. So I take a look at here and I'm like, you know what, that's not one of my identities. I'm kind of stuck. So I'm going to go back and look at my answer. So my answer is 2 times cosecant of 2b. So just like what we mentioned earlier, this is going to be 1 over sine of 2b. So if I take out my identity sheet and I look at my double angle identities for sine, this is actually really close. Sine of b times cosine of b, the only thing we're missing here is a 2. So I am going to multiply my denominator by 2 so I can get that sine of 2b. But if I multiply the denominator by 2, I'm also going to have to multiply the numerator by 2. So I'm multiplying the whole fraction by 1, and I'm just making the function look different. So this will become 2 over 2 sine of b times cosine of b. And now we're like, yes, that's exactly what I wanted. Our denominator is sine of 2b, or my double angle identity. So this is going to become 2 over sine of 2b. And I'm actually going to split this up. You don't have to take this step, but I'm going to split this up just so I can see more clearly. So really 2 times 1 over sine of 2b. And 1 over sine, I know, is cosecant. So this is really 2 times cosecant of 2b, which is exactly what we wanted. I'm going to shorten that just a little bit. So we can say that therefore tangent of b plus cotangent of b is equal to 2 cosecant of 2b. So there we have it. Again, we're just practicing using our identities in these proofs. Hopefully it's getting a little bit more normalized for us, and we just are kind of searching for identities and becoming more familiar with them. If you have any questions, please let me know, and I look forward to seeing you tomorrow.